understanding. Now, that was boring enough. I really hate talking about money. What I really like is the infrastructure that we have behind this operation. And I'd like to start with a little bit of an idea of what we're going to talk. We're going to talk about traditional setups, how websites are built in general, how they are structured, how their servers are deployed, and what is actually happening on these servers, which are like these big machines that you see in the movies or maybe in a data center. So we're going to explain what's really happening in there and why this is so important for, especially for sports betting and casino operations. We're then going to show you a layout and example of our existing infrastructure, how it's built, how it's designed, the general principle behind it, as well as the current layout and cluster locations throughout the world, as well as its scaling capabilities. What happens when a lot of traffic comes in? So during a traffic spike, what happens when demand is lower, and how we are able to save money with our present infrastructure, as opposed to traditional infrastructures that just deploy a number of servers and other resources and then just wait for them to fail one day before performing further upgrades. And lastly, some advantages versus disadvantages in both of these types of setups. Now, looking at the traditional website, those of you that are not very technical maybe have a clue about how this works. You go and get signed up with a hosting company or with a dedicated server provider with a co-location package from some data center. So you basically get a managed server and that's it. Your website gets uploaded over FTP. Maybe you create a database for your WordPress blog and that's it. But what's really happening inside that server? Well, inside the server, inside the black or silver box with a big IBM or Dell or maybe HP logo, what's really happening is that there are a number of other servers that we like to call them, which are like programs. Each one of them does something. One of them may serve a HTTP request. So when you go to www.casino.com, you're basically entering an HTTP address. So there's a server that takes over the request from your browser. This is you, and this is your browser on screen over here. I hope this is visible. It doesn't look like a casino, but we'll get there pretty soon. Now, what's happening is the web server takes over the request from your browser and sends it to the application server, which then pulls the data from the database, a database such as MySQL or PostgreSQL or maybe Microsoft SQL and many other types of databases. It also pulls any images, any kind of static content that you might store in the file system. So that's the hard drive of the server itself, and sends you back the web page that you see on your screen. Now, all these programs, all the software servers need to operate inside your hardware server, pretty much. So each one of these programs takes up an amount of RAM memory, takes up some CPU resources, some processor resources, and some storage. Now, obviously, what's going to happen is that if at some point in time your website becomes successful, and we hope that's very soon, what's going to happen is that the current server that you get or hosting package is not going to face the traffic anymore. You need to scale the setup to be able to serve more traffic. Now, working with traditional hardware servers, what's happening is that you have two options. You either lease them and you pay a setup fee and a monthly fee, or you purchase the hardware and you either place it inside a data center using a co-location package, or you place it on your own connection, which is going to cost you a lot of money, especially the bandwidth, especially in the United States. Now, in Europe, things are a little bit different. Internet is faster, internet is cheaper. Well, except maybe the UK, but that's a whole different story. But in general, that's not going to be a problem. But you're still looking at the initial setup fees for the servers, and not to mention that you're not going to use them all the time, but just in those particular days and hours of the day where your traffic is high. Now, setting one of these servers may take 1 day if you're lucky. I was always lucky because I knew where to look. I was looking for colpub.com.instance, a very good data center. They provide top-notch services, and the setup time can be as little as 1 day. But sometimes when you need a custom configuration, it can take as much as 15 days. Now, if you get 1,000 users willing to go to your casino and bet 1,000 euros each one of them, then you've just lost a million euros because it takes you 15 days to deploy a server to actually handle this traffic. Of course, when you're dealing with the hardware servers, you also need to service the components. Let's say you get a hard drive failure. It can happen specifically, especially when you run a high traffic website that serves a lot of static content, images and pictures, and so on and so forth. Maybe videos, maybe a lot of MySQL queries to display odds. So eventually, what's going to happen is some kind of hardware failure is gonna cause you some data losses and some downtime. And last and not least, you need to have a database manager. You need to have an operating system manager or Linux administrator to actually manage these servers. And I'm not making any references to Windows right now because we all know that Windows is pretty much the worst operating system to use on a server. We're not gonna go there at all. So basically, what's going to happen when you get a lot of traffic into your tiny little Dell server? This is what's gonna happen. It's going to break. It's going to explode. It can overheat and explode. Actually, this is actually happening even now. It's 2013, and we get fires in data centers because of this. So that's it. I mean, the website is down. People cannot wager. People cannot play their games. They have deposited money. Then, if this happens frequently, maybe they start going on forums. They're starting to post all sorts of things all over the internet and damage your reputation and start withdrawing the money. It's gonna This can have repercussions, just like what happens with banks when a lot of people go in and try to withdraw a lot of money. Eventually it's going to collapse, and the same thing can happen to a casino and the sportsbook. It can just collapse by having to pay out a lot of users at the same time. So this all is about how the infrastructure is built and maintained in is built in the first place and maintained over time and improved. Now, this is something that we recognized back in the day when we were also running dedicated servers, and we've been trying to run away from traditional setups as far as and as fast as we could. And we now are running off our own infrastructure, which is very stable, which is based on a whole different concept. We do not use dedicated servers anymore. We use what we call instances. Those are little tiny bits of space, of CPU, of RAM memory, of storage space on whole bigger servers, which are built to last, which are industrial grade servers, which have a lot of RAM. We're talking about a cluster of this can have maybe 128 gigs of RAM, up to a few terabytes of RAM, up to a few petabytes of disk space, which is also mirrored. So that means that if one of the drives fails, then the others will take over, will kick in. There are no data losses. There's no downtime. Um, there are no negative effects on any of the application clusters. Um, the other major advantage we get from using instances instead of dedicated servers is that they are very fast to deploy. We can create them in a matter of seconds, and they can become available and serve traffic within a maximum of 1 minute. Now, we use different type of instances. There can be database instances, there can be PostgreSQL instances, MySQL instances for database. Now there can be web application instances that run our particular code, our sportsbook code and casino code. We can also have messaging, be it email messaging between the server and the customers, or messaging intra-application messaging. So basically, the sportsbook wants to tell the casino that a specific amount of money has been added to the user balance. It's using a simple message queue, which we also refer as messaging. We call it messaging. We also run a number of recipes for mem caching content, for blazing fast rendering of web pages. We're not going to talk anymore about that right now. It's a particular top secret recipe that we have, and it's actually working out very, very well. We've been seeing an increase of up to 800% in the capabilities that our platform comes with after we've been adding caching. And of course, storage, which is Amazon S3. We use a number of buckets, and we also use a number of EBS volumes. So all this, all these things can be deployed or removed in a matter of minutes. And even more than there's even more than that to say is that we can also programmatically deploy resources as demand grows or disappears over the course of a day, a week, a month, a year. It doesn't matter. The code does it on its own. So we pretty much do it. We program the APIs initially when we create the account, and when we deploy the initial resources required to run a particular website, and then everything is automated. We don't need to do anything about it. There's no downtime, and there's no service outage or anything like that. Of course, now when we're talking about all these things, these things, first of all, is that they took years to develop and to prototype and to test and to launch into production. And there are also some other downsides. Like for instance, when we want to purchase and reserve the instances, so reserve a particular capacity for a website that we estimate as being high traffic. For instance, one of our clients that comes in and tells us that we're going to have 5 million users within the first year, then we have to provision sufficient instances just in case the guy will actually have that kind of traffic. And that means we have to put up with a lot of expense to do so. And for every instance, for example, we have to pay an initial reservation fee, and then we also pay usage fee, which is hourly, and the hourly fee can go from seven cents up to $5, depending on the size of the instance. So depending on how much traffic we need to actually serve, and the initial reservation fee can start from $500, from $100 up to 500, and then over in the range of thousands when we're talking about high CPU or high memory instances. And after after we are done with provisioning the initial resources, we have to start working on scalability. Now, our platform is already designed to scale automatically. It scales up and down. So for instance, when we get some traffic spike on one of the websites that we operate, um, we have these little monitors into each one of the instances, and it tells us if the CPU has gone above a specific threshold. In that case, we add more and more and more instances until the CPU demand drops back to 20%, for example. When we need a little bit more agility, we do 20%, or we can do 50% when we need more resilience. And this is all pretty much automated. It takes seconds to create an instance. So when you get let's say 5,000 users during an hour, there is no downtime because the platform scales itself up, and it takes a few seconds to add more instances to serve the next 100 users. And again, this is something that's entirely safe. It's very secure, and we have no need for network managers or database administrators and so on and so forth to manage this whole infrastructure. So just to represent this visually, this is how it looks. Normally, when we are talking about a website that has no traffic or close to zero traffic, maybe 500 users a month, this is how it's looking. We just have one instance that's doing a great job serving up to 500 users per month. But then let's say that the website operator decides to launch an aggressive marketing campaign, and their traffic turns into something like this. 500 times more traffic, we get 500 times more instances. So that at no given time, we have any downtime or any kind of outage or any kind of delays, it just scales itself. It grows from one instance up to this in a matter of seconds, depending on how much traffic comes in. Now, regarding the way we operate instances, a number of instances in a particular location we call them a cluster. Now we are running clusters in the United States. That's East Coast and West Coast for minimum latency for visitors from California or New York or in between. So this is automated. Users get redirected to the proper cluster depending on their location. We also run a cluster in Europe, which is actually Ireland, which is actually the cluster that will be running some demonstrations today. And we also run a dedicated cluster for a customer of ours in Japan. So that's Asia. We are planning on adding more clusters. One of them would be the first would be in South America, actually, in Brazil, and more could come in the close future, depending on how business grows over time. Again, a number of advantages that we get from our current infrastructure is that we use high availability clusters, so that we basically have zero downtime. We've had about 20 or 15 minutes downtime since January last year, which is pretty amazing, I would say. And we've been doing less than 20 hours of maintenance work on our instances and on our infrastructure ever since, which is also pretty amazing. Consider that a network manager, a network administrator can charge up to $100 per work hour. So managing a network of this size would take probably 2 full-time operators if you're running dedicated servers. So that's not the case with our infrastructure. We don't spend any time with these things. It's all already there, and it's all working, and it's all functional. Now, uh, from the fact that it scales up and down, it's on its own. We also know how it will perform under specific amounts of traffic. So we are able to tell how to estimate how much we're going to spend on a particular type of resource, let's say database, or let's say application instances. So the entire platform's performance is predictable compared to dedicated servers, where you need to actually install your own monitoring software, such as Nagios, such as maybe other monitoring applications, to actually give you the statistics and the reporting capabilities that we have. Ultimately, this means we get a lower cost of ownership for the entire platform, and we also have no overhead. We don't need to wait for a database administrator to get back to work to resolve a particular problem in order for a particular website to become functional again. So that's not happening. And like I said, this has been working very well for us for the past almost 2 years. Actually, it's about 2 years, and I would say that it's stable and it's proven at this point, and that there are very few things that can fail um, after 2 years. And again, we would like to stress out that there will be no need of any kind of involvement from a customer's perspective. There's no need to hire any network managers or developers or database administrators. Now, if you run a small website, you're not going to anyway. But the moment your website starts growing, and you're gonna start having downtime, where are you gonna go? You're gonna go to some maybe offsite consultants. Maybe you're gonna be less lucky and run into some company in India, or maybe you're gonna turn to freelancing websites. It's gonna take time, and it's gonna take a lot of money. It's gonna take a lot of trial and error. With us, that's never happening. We don't have this kind of problem.